Hi, mathletes. Today we're going to look at permutations. So imagine four of your friends are running to grab some seats on a roller coaster, and there are exactly four seats. The order they sit in matters because some might want to sit in the side and some might want to sit with their best friend. So, how many different ways could they sit? So, you might want to pause the video here, grab some paper and a pencil, and write down all the different ways that they could sit. When you have that done, you can resume the video and see if you get what I get. Welcome back. So here's the way that I did it. I gave each friend a letter, so friend A, B, C, and D, and all the different ways that I could arrange it were 24. Did you find all 24 ways as well? Well, does order matter? Let's imagine that your school is giving away three different prizes. You could get headphones, a backpack, or a football. Three students are going to be randomly selected to win, but the first person gets the first pick, then the second person, and the third person gets whatever is left. So, would it matter now who's chosen first, second, or third? Oh, of course, because whoever gets to pick first gets the best choice. Of course, it depends what you think the best choice is. Which one do you think would be the best? Which one would you choose? I think I'd take the backpack. So, how many different ways can the three students receive the three prizes? Well, we could list the possible orders of the students picking, just like we did with the order with the roller coaster. So, first, it could be like the person picks the headphones, and then the second person gets the backpack, and then the person that gets the leftover, the third person gets the football. Or it could be backpack, headphones, football, backpack, backpack, football, headphones, backpack, or football, backpack, headphones. So, those are all the different ways that we could arrange that. So, does rearranging the order change who gets what? Well, for sure, because if I change the order, you get a different prize. So, changing the order will change the outcome. In mathematics, we call this a permutation. So, let's investigate permutations a little bit more. Besides listing all the outcomes, is there another way that I could do it? Another way than listing. Well, there is something called the multiplication principle or a tree diagram, and it looks like this. Again, you could get headphones, backpack, or football. So I'm going to put those over to the left. And then I'm going to make branches. That's where the word tree comes in. So let's say, for example, you were the first person, you picked headphones. What's left over? Well, you could choose a backpack for the second person, or they could choose the football. But if you choose the backpack, the second person could choose the headphones or the football. If the first person picks the football, then what's left over for the second person is the headphones and the backpack. After that, there's just one thing left over. So, for example, if the headphones and the backpack were picked, that means all that's left is the football. And then the backpack, the football, the headphones, the backpack, and the headphones. And now, when we write the outcomes, it's going to look like your listings. See, this looks just like the previous page. So, again, there's six possible outcomes. Now, let's look at this new one. For this one, you found a row of lockers in a digital escape room. And each locker has a three-digit code, and there's digits 1, 2, 3, and 4. You can only use each digit once per code. In other words, you couldn't have a 1, 1, 2 or a 2, 3, 4. Well, you could have a 2, 3, 4, but you couldn't have like a 2, 2, 3. Okay, and again, just three digits. So your job is to figure out how many different locker codes are possible. So let's explore them all. And this time I'm going to make a list. Again, you might want to pause it and then come back. Okay, here's what I came up with my list. And again, I had 24 different codes. It took me a long time to do this, but it wasn't hard. Well, what if you say, let's try the tree method? Again, you might want to pause here. And I also did this. And there was my tree method. Okay, so you can see I also got 24 outcomes for this one. But those took a while to do. So I'm wondering, is there a faster way to calculate all the possible codes without listing them or making a tree diagram? And actually there is. Here's a hint. You have four choices for the first digit. Then you have three choices for the second and two choices for the last. Does that help? Think about four choices, then three choices, then 2 choices. And remember, there's 24 possible outcomes. Again, you might want to pause here and think about this before you continue with the video. So this is the way I figured it out. I multiplied the 4, the 3, and the 2, and I got 24 possible codes. This is a permutation. And a permutation, again, is when order matters and I'm not repeating anything. So another way we can calculate possible codes is something called a factorial. And a factorial is a quick way to multiply a number by all the smaller numbers below it. And in mathematics, we use the exclamation mark to show a factorial. So here are some examples. A 3 factorial doesn't mean 3. It means 3 multiplied by 2 multiplied by 1. And the product of the 3 numbers is 6. 4 factorial is the product of the 4 numbers. And the product is 24. And 5 factorial with the 5 numbers. The answer would be 120. So to figure out the possible codes from the previous problem, we could say 4 factorial, which is 24. You'll notice I only used 4, 3, and 2 though, because when you multiply by 1, anything multiplied by 1 is itself. So let's imagine that you're organizing a talent show and you're going to have 5 acts. You could have a dancer, a singer, a pianist, a comedian, and a magician. But only 3 can perform, and you need to decide the order of their performances. Should we list all the possibilities? We could, or we could make a tree diagram, but both of those are going to take quite a bit of time. And you know what I noticed? This is really similar to the locker problem. So maybe we can use that same method. Again, 5 acts, only 3 can perform. Any ideas? Well, for the last one, there were 4 choices and only 3 possibilities. So first I had 4 choices, then 3 choices, and finally only 2 choices, which was 4 multiplied by 3 multiplied by 2. So if I use the same reasoning, if I have 5 acts and only 3 can perform, couldn't I say 5 multiplied by 4 multiplied by 3, which means I would have 60 different ways in which they can perform. So let's compare the 2 problems. So when we looked at the locker problem and the talent show, what stayed the same? Well, I noticed that order mattered with both of those, which is why I could use a permutation. But what was different? Well, I noticed in the locker problem, we used all the digits. But in the one with the talent show, we only chose some of the acts, but we still solved them in the same way. So now let's look at this one with ice cream. So you're at an ice cream shop and there's 5 different flavors. You could have chocolate, vanilla, strawberry, mint, or pistachio. And you're allowed to choose 3 different scoops. Now, in this case, order matters because, in my opinion, the flavor on the top is what your tongue hits first. So for me, it's the most important flavor because you get to eat it first. Okay? So again, order matters, and you have 5 flavors with 3 different scoops. So again, order matters, and I can't repeat any of the flavors. So how many choices do I have for the top scoop? Well, I could get chocolate, vanilla, strawberry, mint, or pistachio. So 5 different flavors. Let's say I chose the chocolate. Then how many are going to be for the middle scoop? Well, now I only have vanilla, strawberry, mint, and pistachio. So I only have 4 choices. Let's say I pick pistachio. So now I only have vanilla, strawberry, and mint left for the bottom. So there's only 3. So just like with the talent show, 5 multiplied by 4 multiplied by 3. So there's 60 different ways that I can organize my ice cream. When we're finding the outcomes and orders matter, again, it's called a permutation. And when we're looking at the number of permutations, we write it a special way, and it looks like this. Looks kind of funny. Got an N and an R, and then I noticed the P. So this P right here stands for permutations. Sometimes we write it like this way. N and R also stand for certain things. The N is the total number of objects. So if it was the ice cream, it would be all my ice cream flavors. I had 5 of them. And then what we selected is the R, and I could only select 3, so that would be the 3. In mathematics, we have a formula for figuring out the permutations, and it looks like this. Oh, wow, that looks really sophisticated, a little scary, but it's not bad at all. We know that the P stands for permutations. We know that the N stands for the total number of objects. The R is the number of objects selected, and we know about the factorial key. Now, with combinations, it looks like this. So what's the same and what's different? What do you notice? I also have a video on combinations, so you might want to check that one out as well. So let's look at our formula for permutations. And let's use our formula for figuring out the ice cream. Okay, so for the ice cream, we know that we have 5 different flavors, and that's my N. So I can replace the N with a 5. There we go. Now we have R, and R is the number of objects selected, and I'm selecting my 3 scoops, so I can change my 2 R's to the 3. Now all I have to do really is simplify. So I do 5 factorial, which is 5 multiplied by 4 and 3 and 2 and 1. Then I do the difference between 5 and 3, which is 2, and that's a factorial. And 2 factorial is 2 multiplied by 1. So now I simplify the numerator and the denominator. I divide, and I get 60, which is the same that I got all the other ways that I did it. Let's try some more. Let's say that you have 4 students and you want to arrange them in 2 of them in a line. How many different ways can you do it? Well, again, order matters. So here's our permutation formula. So that means our N is going to be the total number of objects, which is 4 for our 4 students. And the R is the number of objects selected, and we're selecting 2 of them in a line. So now we can replace our N's with 4 and our R's with 2. Now we're simplifying. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. And then we have the difference of 4 and 2, which is 2. And 2 factorial is 2 multiplied by 1. And we just simplify it. So there's 12 different ways that I can arrange 4 students, 2 of them in a line. How many 3-digit pins could I make if I had digits 1 through 5 and no digit repeats and order matters? Again, it's a permutation. Let's see what we know. We know we have 3-digit pins, so that's what we're selecting, and digits 1 through 5, so we have 5 total objects. We can replace our N and R, and again, I'm just simplifying, and I end up with 60. So remember, a permutation is an arrangement of items where the order matters, and factorials can help us calculate permutations. We can figure out all the outcomes by making a list or using a tree diagram, but those take some time. Or the fastest way is using our formula. And there's our formula. I hope this helps with you understanding permutations and also an introduction to factorials. And again, if you enjoyed this, check out some of my other videos and also check out the video that I did on combinations. As always, thank you for watching.